Afternoon, everybody. How we doing? How we doing on this wet and nasty morning in Southwest United Kingdom anyway? Very murky today. So we've got a few in. We've got a bit to cover today and a little extra thing that's dropped in as well. So we've got a bonus repair come in, which we're going to have a look at first. But I'll get to that in a minute. Morning, Tim and Aaron. I've already said that to you. So morning again. Thanks, Aaron. Yeah, the back is not bro, but there you go. Dids. No finger, but we got something else today. Chris, Milky, how you doing, mate? Stormy. I don't know how you pronounce that. Wakasha? Wakasha, is that? So that's what it looks like anyway. Joe, Mr. Matambly, how are you? Yeah, it's been pretty rough here. I think you've had some advice on your LED. Afternoon, Nick. Just catching up, people. Oh, hello, that jumped up quick. Hello. Where was I? Nick. Yeah. Derek Cooper, afternoon, Derek, and David Tag. Hi, David. Bob's in. Hi, Bob. Oh, how are you, mate? Mike Cass, hi Mike. Brett's in. How you doing, Brett? In for some more hackerage. Rob Tiveridge, hi Rob. Dark overcast. It's been hammering down here on and off all morning, but I think it's eased up at the moment. Tom and Susie going for a drive later to look at all the fall colours. Well, it's not really hit here at the moment. We call it autumn over here, obviously, but leaves are starting to come off, but the trees aren't turning colour yet, Tom. We hope Susie's on the mend. The geese are flying south. Formula One on the Specky. What, ZX or? Which one, Brett? I have got a couple things to the Spectrum arrived. One is in from another YouTuber that's very kindly sent me a little board to build. It's an IC tester or analyzer, IC analyzer, I believe. So I've got a board to do that. A little better. It comes and goes, Joe, to be fair. Like 1 minute I think, oh, this is feeling okay at the moment, ever move about, then all of a sudden it's like, oh, hang on a minute, it's going again. Afternoon, Dave Rhodes. Ken Surtees, rainy Bournemouth. Yeah, it's not very good, mate, is it? Good to see you though, Ken. Hello, Mr. Blue Sky, yeah. John Turner, afternoon, John. You've laid your hands on a CRF320, but it has issues. Whoa, Bob. I've had my eye out for one of those for a long time, and I've not yet seen one really that's any good for less than 4 figures. They go for crazy money, but Manuel Electronics Old and New has done an amazing series on those, and I'm sure you've watched his channel there, Bob, but if you follow through with what Manuel's done, I mean, he's even designed bits for it and everything. I mean, he's the man for that, definitely. Nice day in North Derbyshire, really, David? Daniel, how you doing, mate? It's an emulator on the Pi. Is it a Spectrum ZX emulator, or is it the they did a few Spectrums, didn't they? They did a few. Spectrum, was it something Plus? And I don't know. I'm not a Spectrum aficionado, really. Hi, Benji. Brain there too. David talking. He's got all the sun. Daniel's horrible as well. ZX Bear. ZX Bear. 415, Bob. Whoa, that's a bargain. And he bought some of the gears he designed. Yeah, I mean, I know he had a couple goes at those gears, but what a job he done on that. Hey, Rich is in. How you doing, Rich? I've got 2 or 3 Pis here, all doing different things. I've got a Pi which is which I built as a retro Pi, sort of arcade emulator that emulates loads of the old games as well. So I've probably got those games anyway. I've got one that runs an emulator for the Commodore 64. Is that right? Yes. Yeah, it emulates the disk drive, floppy drive for the Commodore 64. Pi 1641 hat or something like that it is. I don't know, but they do a lot of stuff. Solar powered plant monitors, Benji. Oh, sorry to hear that that's happened, Daniel. A bargain only if I can fix it. Yeah, I reckon. You seem like someone that knows what they're doing, Bob, so I reckon if you put some time and effort into that, you'll sort that, mate. BMC 64, is that a C64? BMC 64? Sounds like a Leyland Mini. BMC 64. Anyway, as I say, we've got a little quick look at something. A little quick look at something that's just come in. It came in with a couple extra bits. John may recognise this. So we switch over to the main camera. And I'll stick my ugly mug up in the corner here. We've got this bag with something in it that needs looking at. But also it came with this. And also it's got like a brother. This one. So it came with both of these. So John, thanks very much for sending the beers in, mate. Always gets your kit on the bench early if there's beers involved, doesn't it? So we've got, I think these, John said that these are brewed sort of local to him. Flack Manor Brewery in Romsey. SO51, that is sort of Southampton way postcode, isn't it? I think John is down near the New Forest. But yeah, I've never seen these before. Apparently they're a fairly new brewery. So we'll give them a try in a minute and see what happens. Maris, otter, barley and wheat. So one is a hedge hop premium ale, flax, and flax Romsey Gold. They both sound very nice. Award-winning golden ale, that one. A refreshing lazy day session beer. Well, that's good for a Sunday, isn't it? Sunday is a lazy day, apart from for me. This one's got a mix of 5 malts and 3 hops. A rich amber ale, real zest and depth of flavour. So originally brewed as a double celebration of both those intrepid World War I pilots and a half-century... Which pilots are those then? Oh, Flax is the... I thought Flax was the brewery name. It is, Flax Manor Brewery. A half-century measure. Yeah, okay. What's it say about this one then? Crisp and zesty. So that's the obviously the World War I biplane there. Doesn't actually say oh, it's basically all of the World War I pilots, not one in particular. Okay. But yeah, a couple nice sounding beers there. So we're going to crack one of those open in a minute. In fact, shall we crack one open now? Let's crack one open now before we open the box. How about that? So John, thank you again, mate. Thanks very much. Much appreciated. Oh, emulator on the Pi. No, I've got like a front end on mine. It does emulate some of the 64 games, but not a lot, Brett. The Pi Hat, you can basically download anything you want. Any of the not tap files, it's the I can't remember what they call them now. But you've seen me use it before when I've repaired the Commodore 64s. Let's just catch up with the chat. What's your opinion on fitting a Bluetooth module to a vintage Evolve radio? I'm not 100% against it, Aaron. If it can be done in a way that does not involve drilling externally anything. If externally it looks identical, then I don't see an issue with that. And again, if you can keep it and switch between the two, so you can switch between the original radio and the Bluetooth module, fine. And again, using all the amplifier side of it. I know people build like, they'll stick an amplifier and a Bluetooth module in a bare case. If you've got a radio that's totaled, you know, output transformer's gone, it's totally bricked, and you can rebuild that and make it into a vintage looking bit of kit with a Bluetooth module in it, I don't see why not. It's better than throwing it away, isn't it? So that's my opinion on it. I haven't really, I know Manuel's done quite a few Bluetooth modules, and is a very much not involved in drilling stuff. I've seen a lot of drilled ones and ones where you can see the display in the window. I don't like any of that. You know, end of the day, all the phones these days have got enough capability to flick through stuff and just push a button. I don't think you need to be looking at screens on the radios. That's my opinion anyway. Oh, Brett's not gone on the C64 emulator. Yeah, it's called a Pi Hat. So it emulates the disk drive. It's the best one pretty much. You can get one that emulates the tape drive, but it's not as good. And not as many games work with it, Brett. Let's catch up. The chat's jumping quicker than I can read it and answer it. I'll see if I can bring that up in a minute, Brett. If you're interested, I'll find you a link to it. Get flacked instead of the finger. Wasn't there a game show with the catchphrase "open the box"? Yeah, that was oh, that thing with oh, Noel Edmonds on it, wasn't it originally? You just got a notification, did you, Benji? Well done, mate. I'll take your pick when Michael Miles take the money or open the box. Yeah, I'm thinking of Deal or No Deal, where they open the box to see what money's inside. So I've gone with the Hedges Hop to start with. That is a sort of like darker looking. So that's not that dark, but it's looking nice. So I'm going to try that. Cheers, everybody. No ways, Brett will do. Rob's radio room's in, and he's gifted 5 people channel memberships. So thank you, Rob. Sir Circus Cattle. Pie Man. Huey Green. I remember Huey Green. Pitco. Welcome, Pitco. And Momo Munster. Welcome. And Lakota Wind. All these names. Welcome, welcome everybody. Right, so what's John sent me in? Well, let me show you. Or shall we no, let's find Brett's link a minute first, because that's he's just asking I'll forget house. No, it's not that. Here we go. Here you go. Here you go, Brett. So it's a Pi 1541 Pi hat for the Commodore 68 128 VIC-20 OLED buzzer LEDs. So it's a bare board. You're going to need a Raspberry Pi, but this sits on top of the Raspberry Pi. So you can see the Raspberry Pi in underneath there. It doesn't come with a Pi, but it comes with a hat. So let's see if we can. There's going to be a big link. Let's paste that in for you. So it emulates the floppy drive. And as I say, it's far better. Oh, I don't like that because there's too many things. You need to get the item number, maybe. You got an item number on these things these days? Oh, we've got a share button. Watch this item. Add to wish list. Item number, here we go. I'll just paste that in, look. God, that URL was 222 letters. Just deleting all of this. There you go, Brett. That should sort you out, mate. But yeah, basically that emulates the Pi 1541. So you just plug it straight into your Commodore 64 and it acts like a disk drive. It even makes the noises, Brett. It's a good bit of kit. It's good fun. I need to design a case for it though, because ideally it wants to be put in some sort of case. So it works with a Pi 3B, 3B Plus or 3A Plus. Actually, if I just go back to the screen cap again. So this is the bit you need to read here, really. I've still got some of my Tropical Crush left. So yeah, you basically need the Pi, Raspberry Pi. You need the Commodore 64 SD card serial cable. Now, I made my own serial cable, it's not difficult. And then you download the latest version of the Pi 64 software on this link. So if you have a look at that link, Brett, then that takes you into the sort of programming side of it. It's easy enough to set up, to be fair. I can do it. If I could do it, you can do it, Brett. You're still on the holidays, Rob. Wow. Good to see you, mate. I hope the holiday's going well. A tease. Afternoon, Jess. How you doing, mate? I bet it's a bit ropey down there as well. Right, so shall we have a look and see what's in the bag then? It's what is in the bag. It's not a radio. I can tell you it's not a radio. Anybody got any ideas what it is? Brett might do. Some people may have this. I have got one here somewhere, but at the moment I can't put my hands on it, but it's about here somewhere. You're welcome, Brett. Have a look, mate. It's, it works flawlessly, that. Anybody? No? How about now? No? Anybody? Any ideas? You can see it's some Sony. What is it though? AN-1, yes it is. It's the indoor unit. Sony AN-1 antenna controller. Now I think from what this is coming from John, who's very kindly provided me with those beers. I think he said it was smelling sort of like a burning sort of smell. Doesn't smell too bad now. Do you want to enlighten us as to what's up with this, John, if you're watching? I don't know, John works sometimes on a Sunday, so he might not be able to comment, but I think I'll get his email up in a minute. Or his WhatsApp message. That's a nice drop of beer, actually, John, that one. Very nice. Okay, it's got an active antenna free. The antenna controller smells cooked and doesn't work. So he suspects that the wrong voltage or reverse polarity have been up it. So all I thought I'd have a look at today is just take it apart and just see if there's anything physically inside that might be dodgy. It says it on the box. It controls antennas. Yeah, basically if you don't know what the AN-1 antenna is, I've got one here. I think I've done a video on it a long time ago. I bought one at the NVCF, as it used to be called. Retro Tech now. They're expensive bits of kit, really. There's one here on eBay. Let's just go to that then. Can we get that up full screen? So yeah, you get all these different items. You get an outdoor unit, which is that grey thing there. You get a telescopic antenna. This is your indoor unit, which is like your amplifier. Then you've got this unit here that's got a ferrite rod inside it that couples it to a radio without an aerial socket. There's various other bits. I can't remember what that is off the top of my head. That's just a bracket for mounting it. It's got all the bits. So if we go through the pictures, antenna coupler. I think that's some sort of coupler again, isn't it? Yeah, that's for a wire antenna, I think. I don't think I've got that piece. So this is the bit we've got. So there you are, that's what it is. I don't know if there's any information on this thing on the internet. I have got a copy of this book here somewhere I say, because you know, it might have a circuit in it for that, I don't know. Anyway, that's what it is. It's basically it's an external antenna that works right up through medium wave and into long wave, medium wave, and into short wave. See, it'll do 0.15 to 30 megs on the top switch. So long wave, medium wave, and short wave, and it'll do 1.6 to 30 megs on the bottom switch. It's got an attenuator and the power switch. That's it. And it works on battery. It works on battery, or you can put DC in there, which is 9 volts. It does say the polarity, plus or minus. So center pin negative, output to receiver coupler, input from antenna module. So basically you plug in this phono connection from that grey antenna thing, goes outside, comes through the wall, bit of coax comes in, phono connector there, and then that goes to your receiver or to your little module. So this should be fairly easy to take apart. So we can slide the lid off and take that off. There's a little bit of signs of battery leakage on here. If you can see that, it's actually wet. It's definitely wet there. I don't know if you can see that. I think how close am I? Yeah, that's as close as I can get. So we've definitely got some battery damage, so that could have got inside the board. I don't know if John's taking this apart either, but see if we can get it where the light's not shining on it so much. Yeah, so you can see there's some battery acid, which I've just wiped off, and also underneath this one, also got some battery juice left over. So it's had leaking batteries. Now I run mine with the batteries in. In fact, mine's probably still got the batteries in if I can find it. I normally keep it here, but I've got the antenna in the shed at the moment because I took all my antennas down to paint the back of the house. So we've got some screws to undo. So let's get it apart and just see if there's anything blown up inside, really. That's just a quick look as a thank you for John for sending me in those nice beers. So we've got some screws, we've got some little ones, some babies. So get them undone first. So this front panel comes off. If it's at the wrong voltage up it, who knows what could be gone. These are made in Japan. Good bits of kit, these. If you can pick up one of these antennas, I'll tell you now, they work superbly well. In fact, I ought to get mine back up really, but I need to put the aerial mast back up. I need to give the outside wall a second coat of paint, and with a knackered back, unfortunately, I can't do any of that. Right, what happens here then? This front piece comes off, yes. That lifts off, yes. Oh no, we've got a, looks like a little switch cover there. It goes on. It's definitely wet in here, so I think it's had some battery juice up it. It's a very basic board, so there can't be much. There can't be much wrong inside here. I mean, I'm sure you can see that there's virtually nothing to this. We've obviously got some circular component there, which looks like it's a filter. Some connections onto the board here. We've got a capacitor. What looks like a burnt inductor. Ooh, burny inductor. Let's take this board out. Ding out. Certainly looks like we've got a burnt inductor there, John. Let's take these little things here off as well, because they're only going to fall off and get lost. Right, what else is stopping this coming off then? Oh, I see, it's soldered to there. Right, so fire the desoldering tool up, because the battery pins are soldered through the board here and here. Don't know what else is holding it on here. Is there something holding this here? I don't know. Okay, yeah, looks like we may have to desolder this as well. But to me, it looks like that inductor there is burnt. But what is the value of that inductor? That is the question. And is it measuring anything? Let's get you in for a look. So can you see the one I'm talking about? This one here. That is definitely burnt. It may have just taken that out, but there is other components on here. It looks like this is like a little daughter board which is soldered on these tabs. I'm hoping that once I've disconnected the battery tags that this board will just lift up, but I'm not convinced. I may have to desolder these as well, but I can't really see anything holding this board in. Okay. Right, we're up to temperature by the side of it. Let's take these off and have a look. Oh yeah, did come off. There we go. Right, are you ready? Okay. Could be that inductor's shorted. That little filter. Potentially the capacitors have had too much power up them. So we could have some dead caps there. but it definitely looks like that inductor's gone. Strange, there's a little tiny SMD resistor in there. I don't know if you can quite see that or not. A little tiny SMD resistor. Everything else is normal through hole, yet they've stuck one SMD resistor in there. Now, have I got my eyes here? I've got one of the pairs. Let's have a quick look to see if I can make any assumptions on the colour of that. Is it the same inductor as the other one? It looks like it's definitely black, silver, brown. So look at the focus on these. We've definitely got brown, black, silver. But I'm not sure if that one's brown, green and black. I can't tell. I'm going to have to get the microscope out. But I reckon that's going to be the component that's failed. I mean, really, trouble is with an inductor, what does it do? Is it doing something to do with the bands? Is it acting as a filter? If we were to just bridge it out, which we could do, we could bridge it out and it would work, but it wouldn't work properly. So we need to know the value of that inductor. I wonder if the board has got any information on it. This is going to be a nightmare to pin out because you can see it's a ferrite core with a lot of different connections on it. One doesn't appear to go to anywhere, but I haven't got a clue on that. Again, we can have a look under the microscope to see if the insulation's broken down. I mean, it doesn't look great. But that would be a bit of a nightmare to work out how to wind that. Look how many different windings are on it. What on earth? Yeah, that would be probably the best part of a day's work, very gradually unwinding each piece, making notes of it, videoing it, everything to try and get to the bottom of that. That would be an absolute pain. So let's hope that isn't the case. Let's plug the microscope in and see how we get on. Right. Has that come up? Yes, it has. Okay. Let me have a look through. See if we can get this. First of all, look at that filter. See if the insulation's broken down on that. Okay, difficult to know. Let me put that under the on the scope on the picture for you. Get rid of that. Let me just move that about a little bit. No, wrong way. So it looks like we've got two wires that are covered in some sort of sheathing. Doesn't really look burnt. I mean, you can see where we've lost the sheathing on that bit. If I can pull it into shot. I'm so zoomed in here, it's difficult to show you. Yeah, there you can see a sort of bare wire where that sort of little bit of sheathing has come undone, but I don't think that's broken the, I don't think that's the insulation. I think that's just something they've used in the factory to join the two wires together to make it easier to wrap around, if you know what I mean. Just have a quick oh. Yeah, that's just some sort of coating. I don't think that's shorted out there. Yeah, I don't think that's an issue. This doesn't look burnt. None of this looks burnt. The green enamel looks all okay on that. So I think we're good on that. I don't think there's an issue with that, but apologies for it being in so close, but I can sort of zoom you out a bit. Let's just refocus. We've got to go up or down to focus. Up. I can never get the hang of these. I'm trying to get it in the center of the screen for you. There, that's as good as it's going to get. That doesn't look burnt, does it, to me? How bizarre. Am I up to my maximum brightness on this? Yeah, I think that's focused, isn't it? That's a little bit better. That looks okay. Luckily, I don't think we've got any burnt toroid to worry about there. So let me just go back to that. I'm going to append the board somehow. Let me see if I can put these beside it, and we'll have a look, see if we can work out what this is it going to work? It's going to be better that way. Yeah, what this thing here is. Let me position the camera first. Oh, I had it then. It moved again. There she is. L13 is burnt. Oh, Bob, you've got a schematic, have you? Pop us a link, Bob, if you've got it. Pop us a link to the schematic if you've got it there, Bob. Being you have the spanner of joy. Yeah, it's a bit bizarre, isn't it? L13 is the 88 microhenries. Now, I have got some inductors. Where's my little box of inductors? I haven't got a lot of inductors, mind you. because they do very occasionally go open circuit and kill a radio dead. Well, I've only had it once on a Roberts R861. I can't get my blimmin' inductors out now. Come on, what have we got here? Right, inductors. Inductors look a lot like resistors. Some people do get them confused, but you can see there's clearly an L, not an R. The R11 is the piece beside it. So Bob is saying 88. So I've got a 47. I got a 4,700. 4,700. And a 4.7. That's mH, that's millihenry, isn't it? So no, I haven't got one unless I've got any others anywhere. Anyway, we need to have a look to see if it's toast. Thank you for the link there, so if anyone wants to have a look at that, let's have a look, see if I can down it. 5413. I probably have got this one, to be fair, but let's have a look at it on the screen. AN-1. Oh, it shows us how to take it all apart there. Look, we could have saved ourselves some trouble. And we have got some indication of the windings there as well, so we can ohm those out. So they should be pretty much a dead short, both of those windings. That's useful. Switchboard. And there we have L13, look. So let's have a little look and see. So L13 is in parallel with R11, so it's doing some sort of filtering, isn't it? Sort of linked to everything. So we've got our power coming in here, going through L11, so we need to check C11 and C12, because if that's too much power up it. These are rated at 16 volts. Might be lucky if someone's put sort of 12 or 18 volts in it. These may have survived. I think L11 is that toroid. Why it's got so many connections to it, I do not know. So the power would have come through here. If it burnt that one out, open circuited that one, it would have shoved the power through R11, so we would need to check R11. And maybe C13 would have blocked it going any further this way. So that means we've got 1, 2, 3, 4, 5, 6, 7 components to check. And we also need to find an 82 microhenry Inductor. I don't think I've got any kits with inductors in here. Anyway, let's get back onto the thingamajiggery. This is a bit of a deviation, so apologies in advance for deviating from our main event, which is the Hacker Herald, Marine Herald. So yeah, unfortunately I've got none of those. I have got some weird toroidal thingamajiggers myself. I've got some of these, which is probably similar to that filter, to be fair. Just two windings, but a bit bigger. So if that was open circuit, no, I don't think that's right. Anyway, we've got some things to check, haven't we? So let's get the microscope out of the way. And I'm going to disconnect the legs on some of these because they will affect each other. So I'm going to disconnect a leg on the inductor. Let's zoom you out a little bit because you're in way too close. So I'm going to disconnect a leg on the inductor, which I'm going to assume is open circuit. My tip on my desoldering gun needs changing, I think. Let's see if that's got them. Right, so basically an inductor is a coil of wire, pretty much. So it should give you fairly high resistance. I have got the LCR meter, so we can connect it up and see what inductance it is. So shall we do that? Yeah, well, I might be totally barking up the wrong tree and it's perfectly okay. So let's connect it up and push the button and see, shall we? It's reading 0.01 microhenries, and it should be 82. So, yeah, it's gone. It's history. See if I can hook onto the resistor as well while we're in here. That is reading basically 220, roughly 224 ohms. Let's have a look what that should be, unless anyone can remember. 220, so that one is all right, the resistor. But L13 is definitely gone. So we know the resistor is good. Let's see what that reads as. Oh, that's a rubbish. Let's just put it on resistance, this one. So I'll just put my meter on resistance. Let's see what it's reading resistance wise. Should be a very low resistance, which is reading. It is reading 2 ohms. Yeah, it is reading. But it's definitely not right. It's definitely not reading correctly as an inductor. Let's just go through that again. Yeah, it's not an inductor anymore. It's definitely not reading any inductance. Remove it. I've lifted a leg on it, Derek. I've desoldered one leg of it. Are you saying that the other leg would affect it as well? Let's take the other leg out then. I have lifted a leg. Do I see Mr. Christophe in the house? Took it completely out now then. No, it's still reading at minus 0.3 inductance. And it does smell. It's minus 0.1 microhenries. It's gone. It's gone. And what's George saying here? Not to be confused with bass. A bias T. Let me catch up with the chat because Mr. Christophe's in the house and I think I've seen lots of other people dropped in, so let's say hello to everybody. L12 was toys have not been balanced. Afternoon, Rob Head. How are you doing, mate? Dawn, afternoon or evening to you. George, you've got to get with the program. This is the Sony AN-1 antenna controller, mate. Just got in from shopping. The active part is in the actual antenna itself, Derek. Yes, it is. Don's got Hacker Herald waiting on the bench. No, there's no. It's all potted apparently. Bizarre. Afternoon, Les. I'm sure that John said the antenna part is okay. I don't know how he got to that. Bill, how you doing, mate? Baked. Silver, burnt and buggered. Yeah. So there we are. We need an 82 microhenry inductor for that. I've got to check the other components, but we're not going to mess too much with that today. But I just thought we'd have a quick look. And we'll get maybe a kit of those little inductors. If I can find a kit somewhere, then we'll get that replaced, and I'll have a few in case I find any more in the future. But yeah, John, you'll have to talk to us about the rest of it, the outdoor unit, because we can repair this for sure, but whether it's done any damage, like someone said there, to the FET is another matter. So let's just pop that. Did that go that way or that way? I don't know. Let's pop that to one side, not losing any other bits. So as we don't upset George, we'll get the hacker in shot very quick for him. And it depends which model of Herald you've got, Don. Which one have you got, mate? I need to just go and get something to put this in a minute. So which model of Herald have you got? Is it the RP30 or the 35? Because the RP30 is the one like this that's got the AF117s, well, it hasn't got the ones up the top. It's got one up the top, not two. What can I put this in a minute? No, I'm not going to lose any of the bits. I've got some of those Ferrero boxes here somewhere that Mrs. Cruncher likes to have. Ah, there we go. That'll do it. That'll do nicely. So that's pending, John. To order some parts up, and then you're going to have to take it back and try it. If it's a problem, then you've got a blown head unit. I know I have got some spares. I know I have got some spares for the AN-1, but I'm not sure what spares. I may have another one of those antennas. So it might be that I can connect it up and see if it's working before we send it back to you and give you the hassle of it. Right, so where did we get to last week? We got the thing working, didn't we? We cut the shield wires off of the AF115s up the top, and these, amazingly, down this side were all working. So yeah, I think you'll find if you go on the one of the hacker forums has got some information on the AN-1, shows people that have cut them apart. The grey piece is all potted inside, and to get to the FET inside it, you've basically got to rip the thing apart. I'll have a look and see if I've got well, I can obviously try it on mine, John, because mine's still up on the mast here. I just have to get the ladder up. We'll get Mrs. Cruncher to get the ladder up, and I'll connect the whip on and see if it works after we've repaired it. At least that'll you'll know that bit of it's working. Might be worth sending yours up if that's the case. So if it works, which is highly likely going to, then you're probably going to need to send yours up for me to have a look at. So yeah, we've got a few things to do. We've got lots of nasty capacitors in here. We've got an Elka mode, 300 microfarad, that's going to need changing. We've got a Dali in here, this blue thing. Both nasty, change on site caps. We've got a Philips one up here. This is the one that's on the board the wrong way round. They put it as a minus when it's actually a plus. I think these have been out and possibly been done. But again, do you risk it? We've got no cover on the... Let's get you in a bit closer. We've got no cover on one of the transformers there. Let's get you right in close so you can understand what the hell I'm going on about. And we'll do it properly. We'll do it properly. We're not going to mess about with... We're not going to mess around with silicon. We're going to do germanium. We're either going to zap these or we're going to replace them with equivalent germanium transistors. Ideally, I'd like to keep it original, so I want to keep AF117s in this section, and I want to keep AF115s in this section. The only thing I could do is I could put AF125s in there and 127s. You can get the light to stop shining on it. There we go. So this one has definitely been changed. It's been out. Someone's had a go. Unfortunately, one of the upstands is missing off of the board. Oh, you've got the RP30, so yeah, that is the same board as this then. Don, that is exactly the same board as this. So if you look at your board, it will be, I mean, this is marked M18381. This is any other model numbers, but yeah, your board will be exactly the same as this one. Exactly the same. And when you do it, watch this capacitor here, because the positive comes off that back wire, and on the board it's marked negative, but it is actually positive. So watch this cap here, Don, which is C20. So on the board screen print, it's wrong. So it's wrong on the screen print, but it's right in the manual, I believe, on the schematic. So yeah, your board's going to be exactly the same as this, with these AF117s in it. And I think from memory, the RP30's just got one up on the switch panel up. If I can get it in shot. Not really. The switch panel's under here. You have got two, but you'll only have one on yours. I'm zoomed in a bit far, so you can see there's an AF115 and there's another one. There's two on this board. I think there's one on the RP30, not two, but you need to deal with these as well. So you can put AF125s in them. You can try the Russian GT322Bs or Vs in them. You can still get hold of AF127s and 125s, but they cost an arm and a leg. If you're keeping it and it's yours, just zap them, Don. You're a clever chap. You can get these out, zap them and put them back in, no problem. No problem. But this section is working now. The other section on the switchboard wasn't working, but we got it working by lifting the legs. Because this is a Marine Herald, we're going to keep it as accurate as we can. We could stuff this alka mode, but I don't know that it's that critical. I think we're just going to end up putting a, I mean, that's a 300 microfarad, so we're going to end up putting a 330 microfarad in there to get rid of this one. 10 volt Dali, sorry, 10 microfarad Dali. Again, that's just another 10 volt axial across there. What have we got there? Is that 10? Or is that 100? Can't even read that. 2.2. That's not good then. Yeah, so that's the plan then. Today is we'll see if we can get this section done, or we'll see if we can get the switch panel done. Probably we'll go for this section today. I'll zoom you out a little bit so you can see the complete board. This is the IF amplifier board. So L4, L5, L6. I believe the signal comes in from here, goes down through here, then goes back up to the volume pot. Where does it come from? orange wire through there. Just talking to myself for a minute. There. Yeah, so the signals, it basically comes in the top of the board, comes down through the board, through the IF stages, up through this yellow cap to this green wire, and then up from the green wire through this socket here, which I can't remember. Is that a headphone socket in this one, or is it an tape-in socket? I can't remember. Tape recording. Yeah, so it's a tape recording socket. So it goes through the tape recording socket and then into the volume pot. And from the volume pot into the amplifier. So we know the amplifier is good. And then we know this section is working because it is currently working. So no issues there. Yeah, no worries, Don. Crafty hen, nice, Tim. Comes from Oak Age Crafty Hen and Tesco last week, very nice. So yeah, we've got, we don't know whether these have got shorts or not. It is working, so it might be that someone's already gone and done this job for us, but we're going to take these three out. I'm going to mark them 1, 2 and 3. We're going to check them for shorts. Even if they're not got shorts, we'll zap them. Let's zap them. The other thing you can do, and I've never had much success, but Andrew Alsford did a little video on how to remove the caps on these. So you could, in theory, put an AF127 in there and stick that cap, silicone it back on top of it, or arrow dot it, or whatever you wanted to do, and it would look exactly the same. Elka mode, I could do something with that, but I'm not going to. I'm just going to change it. So I'm going to start pulling this apart. Start desoldering it all. Now we have got a shorter stream today. Mrs. Cruncher's at work, but she'll be home about 5 o'clock. Sounds like we've got a partial blockage on the suckering machine. Better. So let's take this Elka mode out first and just have a look to see how fantastic it actually is. It's gonna embarrass me again now, isn't it? It's gonna work perfectly. It's gonna be bang on 300 microfarads. And everything I say from there on in will be a load of rubbish, won't it? So there we are, Elka mode. British made, patent applied for. TCP WM 8837. I don't know if that tells us what age it is. Can we date it from that? Because I mean, this would be 1960s, this radio, wouldn't it? Somewhere around there, mid to late 60s. I would say probably mid 60s. We did date it last week, didn't we? But I can't remember now. So 300 microfarads at 10 volts. And what do you reckon that's going to read? I reckon that's going to be I reckon this is going to have gone high. So let's have eyes down, looking, and we'll see what our 300 microfarad capacitor reads. So place your bets. Have a guess while I see if I can find a 330 to put back in there. I think 330s are in short supply at the moment in my stash. 3,300, but that wouldn't do it any good, would it? 330s, but massive ones. We don't need a massive. What's that one there? 16 volts. What was that? 10 volts, wasn't it? Yeah, that'll do then. It ain't the best brand cap in the world. It's RS's own brand. RS Pro, jack on. Yeah, we'll do a bit of zapping for you, Bob. Sorry, Don. Before you go bed. And Mike reckons it's going to be shot totally. Dirt 410. Just in time, Martin. How you doing, mate? You've been watching on the Echo show in the kitchen? No, I mean, these Dallies, these and the Plessy ones are all replaced on site, to be fair. Back in the day, they would have been fine. They do tend to creep up in capacitance with age. They don't kill the radio dead, but they do strangle it a bit, if you know what I mean. They strangle it. So yeah, that's the three different type caps to look out for. We've got a couple examples on this board here. So you've got these ones here that are coated with like a blue plastic, marked Dally, D-A-L-Y, and you've got these TCCL commodes. They do these in black as well, but they're still marked L commode. Not very reliable at all. There is other ones that are a problem. These are the Plessies, the red and black with the yellow wrapper. So that's the three types that you don't want to be leaving them in. Even if it's working, get them out, because you will find it improves. Well, it depends where they are in the circuit. Right, how are we doing? Are we ready to go? So that's reading 590 microfarads, look. It should be 300. So it's nearly doubled. Now, back in the day, that probably wouldn't have been too bad. What are they used to be? -10 and +50%. So that is, if it's 300 and it's now 600, it's 50% over, isn't it? But that's pretty high. Who got anywhere near that then? 590. We got any in the 500s? Multi went 750. Whoa. Potentially could have been right. 470, 623. I think 623 is closer than 470, 537, 390. So there you are. I think that, I'm trying to think who that was won that then. Was it Tim? No, it was Martin, I think, with his 623, wasn't it? So yeah, not good. So we will need to put that one back in, but I'm going to leave it out for a minute because it gives us a better chance of getting this out. You haven't got that cap in the way, so I usually take that cap out before I get to this. And as I say, unfortunately someone's already been in here, and it's not a major issue. Some people take these little ferrules out. I don't know if you can see the little upstands here. See these little pieces? These are like a little tiny socket soldered into the boards, and the legs of the transistor go into them. Well, someone's obviously had a problem with this one because it's just not there. It's disappeared altogether. So we need to find another one of those and put back in. We don't have to. It's soldered to the board. It's easier to get them out, I suppose, if these... it's just a botch, really, but... you know, someone's owned this radio, they've managed to get it going again, so fair play. They didn't get it going on shortwave because it didn't work on shortwave, but they did get it working on medium and long wave, which is all good. So let's desolder this one a minute. Let's flip the board. See if I can get it. I've got this blimmin', I don't know what it is, keeps coming up on the screen. Damn Google reminders about something or other, you know. So you can see the capacitor, the resistor. What? Yeah, the transistor hanging down below. So it's going to take most of the solder out for a minute. Don't really want to overheat it too much. 2, 3, where's the fourth one's there? Right, let me have a closer look then. See how much solder we've still got in these, because these are little tiny sockets there, soldered to the board in most cases. Looks like we have got all 4 sockets, so they must have snapped the top off of one of them then. So once you've got the solder out of the sockets, the next thing you need to do is get the old forceps, grab a leg, and get your soldering iron, which mine isn't even switched on. Stick a bit of heat on the socket itself, not on the board, and lift the leg out. That's one. Two. Gonna come nicely. 3. And the last one. There she is, all shiny and disconnected. Danish, how you doing, mate? Paul, Gavin, how are you? Jim, hi mate. Dull and cold Dundee. So we're going to name that one number 3 because that's the last transistor in the circuit. We're going to name it, we're going to label it 3. Let's put that one to one side. Moving swiftly on to the next one in line, which is this one here. So again, they're all on a line, and Hacker have been good enough to mark on the board which leg is which. I mean, someone's had a good old graunch at this one. I don't know, that one might be original actually. This one might be original. It doesn't look like this has been messed with, this one. Yeah, that might be original then. So someone's just taken out the one that was dodgy, which is good practice, I suppose, isn't it? Rather than blanketly ripping out stuff. But maybe back when that was done originally, they didn't have the reputation that they got when they started going wrong. So as I say, I'm just taking out as much solder as I can with the desoldering tool. Don't want to overheat them really. And I'm going to try and pull them out, pull each wire out one at a time with the forceps. So again, I'm just going to heat the ferrule. Come on. You don't want to come, do you? Okay, I'm jamming on something there. Shouldn't be. Yeah, just shorter wires, that's all. So that's that one out. And the next one. And the next one, shield. I'm a bit close here, aren't I? But, you know. And the last one. And there we go. I'm like a dentist and I've just extracted another one, look. Another AF117. That was number 2. That's a number 2. And what I'll do is I'll put these back in the same position so we won't mess with the IF tuning, hopefully, although it is worth just going through and giving it a little tweak. Right, and the last one, it's up here somewhere. This one's definitely been got at. Yeah, this one's definitely been got at. Someone's had this one out and changed it, I think. I mean, back in the day, you would have been able to get some these, you see. So, in fact, well, I did buy a load from Burkett years and years ago when I first started doing this sort of work. Before I knew any better, I just thought, whoa. I've got all these transistors going wrong. I need to get replacements for them. So I've actually got a Burkett's receipt somewhere. Hang on, we've got 2 wires going through there. What's going on there? I think they've left the old wire in. I can't remember, it was somebody sent me a message saying they're going up to somewhere and they were going to have a look in Burkett's because it's still there apparently. Yeah, one of these wires is not connected, I'm sure. Unless someone's stuffed 2 wires in there for something else, which is wrong if they have. No, there's definitely only 1 wire. Right, so same process again really. You can't see what I'm doing because the camera's in the wrong place and I'm zoomed in too close really. So I'm up here. I'm just going to heat up and pull out the wires one at a time. This should be easy because it's a nice long transistor, unlike the first one, or the second one. First wire out. Second one. This is the one that's got 2 wires in it for some reason. Yeah, I think one is the previous wire from the other transistor that would have lived in it before. Let's try and get the wires because they're a bit crossed. As I say, this radio is working, but we're doing this purely because it's a rare radio and we want to restore it, not just get it working. We've already got it working. I'm sure it will go to a new home at some stage. So that I've got a nice collection of hackers. I haven't really, well I might have somewhere to store them. I don't know, we're looking at options at the moment as to whether I sort of maybe look at going sort of not quite full-time YouTube, but a lot more hours than I put in at the moment on it, shall we say, and having a different workshop set up. So that's, you know, potentially something. So there we are, there's the other one. Safely extracted, and number 1. So let's deal with the zapping first then, or shall we get these out as well? We might as well get them all out, haven't we? We've got these as well. If we're zapping, we might as well do them all. So what have we got here? I'm going to call this one number 1 and this one number 2 over here. But I can't even get anywhere near this to call it number 2. Oh, steady. Number 1. Let's get these out as well. Same process. The legs are all over the shop on these. Much more fun to get out. Especially the other one. I should have done the other one first. Always best to do the hardest one first. Blocked. A nice pace desoldering tool would be very nice one day, as would be a proper solder extractor, fume extractor even. That's that one. Where's the other one? This is fun to find these. That one looks like it is there, maybe. Sort of almost come out on its own. Well, that's nice. Let's just try that one as well. Both of those are free. Wow. I've already disconnected the shield wire, which was that one. So let's just get rid of the solder out of that. And the other one is down there. That one there. Didn't quite get that one. There we are. Another one extracted. Number 1. So mustn't get those mixed up, but that is an AF115. The other one's an AF117. This is the hardest one to get out because it's in amongst all of this lot. We got one there. One there. Well, it was moving, but didn't quite get the solder at the ferrule. Got it. So that one's disconnected already. Where's the other one going to then? Where are you? We got one. Stuff's right up in underneath there, I believe. I think it's up there. Yes. Well, they came out a bit easier than the other ones, to be fair. See, that one that's sort of like holding on a little bit, I think, but needs a bit of heat to help that one on his way. There's our number 2. So let's keep those separate. Let's put the chassis out of the way for a minute. And let's get these on the bench for a check. So this is the IF. Let's put them on that centerpiece and I can zoom in on there so I know where we are. Let's catch back up with the chat because that's making my head sweat. Whew. Let's catch up. Let's catch up. Let's catch up. Banana bread, very nice. Benji, I have sampled that before. That's catching up, catching up. Let's get the old hedge hop back in again, because that's quite nice, John. Zapping time. Diabetes website, okay. Derek Taffman, afternoon to you, mate. And a visitor. No worries, good to see you in. A non-alcoholic drink. Dry as a possum's pecker. A possum's pecker. Thanks for subscribing Dave's Everyday Channel for the future. Welcome, mate. Sounds like that's another YouTube channel we may want to have a look at. Dave's everyday channel for the future. It doesn't seem to be Benji's, because I always thought the black one would be the shield wire, but very often that's the collector. I mean, in this particular one here, the black wire is the shield. So we've got white collector, black shield. We got earth is the base, and orange is the emitter. So no sort of black. I would have always put black as the shield wire, but for some reason I've seen it on the collector before, and it's been random, because very often you've only got one wire covered, not all four. So you'll find that you've only got one wire, so you think, well, that must be the shield, but very often it's the collector, or it might be the emitter. It's just random, and you can tell which wire is which on these, because there's a wider gap at one end than the other. So you've got your collector, then you've got a gap, and then you've got your shield, base, and emitter, which are all uniform, but the gap is bigger on one end of the transistor. So that's your collector and your shield. So you'd always know what those two was. I'm sure that's base and emitters, the other ones. But there's plenty of diagrams on the internet showing you which is the correct pinout for those. Right, let's have a look. My leads are very ropey at the moment on my key sight meter. I wonder if this one's got batteries in it still, because this, oh, I think I've broken the probe off of this, haven't I? Or did I solder it back on? I might have soldered it back on. I can't remember. Oh, cool. Yeah, I did. I soldered it back on. My FET meter. So let's just have a quick look, see if this is working on resistance. So ohms. Just. Yeah, it's wandering a bit. The leads aren't great on these banana plugs and screw on endy bits. So the zero adjust isn't right to start with. So I'm just playing about with this meter a minute, because my other meter has got poorly probes and it doesn't read resistance very well. So I'm just on the resistance times 1 scale at the moment. So just zero that one. Yeah, these leads are a bit tarnished, to be fair. No, that's not going to be any good. I need a digital meter, really. A digital meter is far easier to read the ohms, so we'll just use the LCR meter for now. Resistor, enter, okay. So yeah, I'm just going to use the LCR meter. And what we're going to do is connect one leg. I'm going to use just the black leg to the shield wire. So the shield wire is connected to the case of the transistor. It's not connected to any of the other junctions, so there should be no continuity between any of these. I managed to break my little stand for that, but that might just hold it in place so you can see it a bit. Ah, that's a bit better. Look, okay. So if I connect these, it should stay as like that sort of reading. There should be no reading basically. So let's go to the collector, and that's not really changed. There's no connection between the shield and connector, shield and collector, base. Decided to turn itself off now. Base. No, that's good. And emitter. Good. So that has not got any shorts, according to that. Let's try another one. That was number 3, so that was the one that had been changed. Number 2 looked like it was an original. This one I don't think has been changed. Let's just make sure the legs aren't touching on this one. Do the same then. So to collector first. Now we've got a resistance reading. So that has got 164 ohm short between the collector and the shield. So let's try the base. Nothing between the base, and just make sure that we got it on a soldered piece. No short on the base to the shield. Let me just double check that. Let's try the emitter. Okay, so we've got a short to the emitter as well. So we've got a short to the emitter and to the collector on this one, but not the base, strangely enough. So we've got shorts on transistor number 2, but nothing on number 3. Place your bets for transistor number 1 then. Come on down at number 1. Do you think this has got any shorts? There's no dramatic shorts on it, which is why it was working. Definitely that transistor number 2 would have been holding one stage of the IF back a bit. So by zapping it or changing it, we will improve the reception of the radio. Ben, how you doing, mate? Andy Tobin, how you doing, Andy? Welcome, mate. They are very, very similar, Bizarre. If you look at the original Mullard handbooks, they give you different purposes for the different transistors. I've got one here somewhere, but I can't get to my library at the moment because Mrs. Cruncher's blocked me in. But it's yeah, some they say it's to be used in an IF, some they say to be used in an oscillator. Yeah, very strange. Some for amplification, but they're virtually the same. You could put any of those 4 in here and it would still work. Hi Sandra. Warmish. We're okay, Derek. Still got the old back problems, you know it. Buy It, Fix It has a video this week repairing a peak meter. Really? Normally it's just the leads on the peak meters. Right, okay, what do you think of this last one then? I think we're going to have... This one might be okay because it has been changed, you never know. So again, we'll connect on to the shield. Let's pop it on. Resistor mode, giga ohms. Collector, fine. Base, fine. Emitter, fine. So we've got only one of those 3 transistors that's got shorts, which was number 2 in the middle. So it was getting through the first IF stage, it was getting bottlenecked by the second, and then the third one was just amplifying what was coming through, which is why it was working. So, yeah. The one in the middle is the dodgy one. But we're going to zap all three, because you never know how close those tin whiskers are going to be to the edge of that can. They might be micromillimeters away, ready to jump on at any stage and short it out. So bear with me a second. I'm just going to have a quick whittle, and then we'll be back and check the other two out, which we know have got shorts because they weren't working until we pulled the shield wires. Won't be a sec. Right, en route back. Oh. Let's pick my ESR meter up before I run over the leads. Okay, that's those three. Let's try the other two then. What have we got here? Number 2, which is rubbing off. I think that's number 2. Yeah, let's just write that on there again. Number 2. Let's try this one then. Dids, how you doing, mate? Why can't a multimeter used to check for shorts? It can, but my multimeter has got dodgy leads on it. Unfortunately, it's a new set of leads, Dids. The other multimeter is wandering all over the place. It's not zeroing properly. So if we look at this, we look at my multimeter, put it onto ohms, connect the two leads together. It should show a dead short, shouldn't it? It's like 0.01, something like that. So it's showing 5.8, 5.9 ohms. So if I wiggle the leads, look. If I wiggle the leads, 3 ohms, 2. That's that one. This one here. 1 ohm. You know, you'd expect a bit of resistance in the leads, but you know, see 0.9. Look, I'm getting better. 0.6, 0.45, 0.39, 38. So basically, I need new leads. That's why. That's why, mate. Hopefully, that's cleared that up for you. I mean, that's probably gonna. Yeah, so that would work now, but they're just not reliable enough. Yeah, if I wiggle them again, they're all over the place, you know. So there's obviously a bad connection where this meets the base of the lead. Now, Rob Cross very kindly bought me these, but they get a lot of hammer. They're fluke as well, so they are good quality leads. You know, they are good quality leads because the ones I had before went the same way, really. The ones that came with a meter, the Keysight ones, went exactly the same way. So, lovely meter, but on resistance is not working very well. Seems to measure voltages and that okay. I don't know why. For some reason it doesn't like resistances. So that's hence why I'm using this one. Has that cleared that up for you? Joe Fennick, how you doing? And Jeer both jumped in. Welcome. That was the processor, Derek, was it? Did he manage to get another processor for it then? More shorts in Miami. NorCal. Okay. Very little difference then, Bizarre. Device been in Extrema. Yeah, that's why, Joe, unfortunately. Right, that's why I'm using this one. These are pretty reliable, to be fair. So let's zoom it back in again. And we'll have a look, see what this one, these are measuring. So number 2, so again I'm going to connect onto the shield wire, which is the one with black sleeving on. Turn it on, and we're in resistor mode. So to collector, 33 ohms. Houston, we have a short. So that's collector to shield, or to the case. Let's go to base. 171 ohms, short to the base. And the emitter. 3 mega ohms. So there is a little bit of a short there, but not as bad. It might just be there's a bad connection there. Yeah, that was definitely ohms, wasn't it, that? So yeah, number 2, big shorts. Big shorts, little body. Not like me, big body, little shorts. Oh dear. You fool, Graham. Right, okay. Number 1. I'm in number 1. This is in the switch panel. Right, so let's go from shield to collector. 118K. So yeah, we've got a short there. Base. 379K. Emitter. 10 ohms. I've got virtually a dead shortlet on the shield to emitter, so no wonder shortwave would not work. So we got three out of 5 have got shorts. Hopefully you're still with it, Don. You're still with us. We haven't lost you. North California. Yes, he contacted the manufacturer and they sent him one. That was good of them. Because at the end of the day, they do repair them. They offer a repair service, which isn't crazy. I've sent one back to them for repair before. And it came back. I can't remember what they charged me now, but it wasn't like crazy money. But he did very well to trace it to that. Which peak was it? Was it the ESR meter, Derek? Right, okay, so we have issues. Let's turn that off for a minute. We don't need that. So next thing we've got to do is prepare for zapping. Zapping preparation. So what we need is a fairly hefty power supply. Can I connect my webcam up and stick it over there somewhere so we can see the meter? Probably can, if I can twist the legs correctly and find the lead for it. Did I pinch the lead? Did I pinch the lead? No. I've got a feeling I pinched the lead for it for something else. It's a really strong lead, that one. No, here we are. No, it's not that one. It's that one there. So, no, I don't know what I've done with the lead. I've pinched the lead for my. Hang on, that's it, I think. I pinched it to charge something, I believe, because it's. Hopefully this won't stall the whole live stream, but let's see if I can plug this in and I can show you what I'm doing to the. I would do if the camera would stay put. Let's tidy some stuff up so as it'll stand a bit better. These Gorilla Pod things are very good, but they take some setting up. Right, let me see if I can get my webcam loaded up. Will it load up? Yes, it will. What sort of picture is that though? Can you see what I'm doing? Is it close enough? Not really. Let me zoom in. Settings. Ooh, position. Zoom. Okay, zoom. Pan. Pan. Okay. Right. Hopefully you can see my multimeter bench power supply, and it is a bit wobbly because I'm knocking the lead every time I touch this. So let's unplug these leads for a minute. So if I turn that on, you can see I've got a dual power supply, and I can link the power supply with these two, with this bar in the middle here. So I've got basically 32 volts available on each side. So if I put both of them to their max, both do 32 volts each side. Yeah, so I've got sort of 64 volts there available. Sorry about the light, I'm not sure which light's shining on us. This one here. Right, yeah, so you can see I've got 64 volts of zapping capacity. I tend to zap at 25 volts, and I've got this tracking button in the middle. If I click that, it should, and it doesn't like it because of currents. What's going on there? It doesn't like that. No, I'm not. So anyway, let's just loosen these. So what I'm doing is I'm now joining the two sections of the power supply together with that little buzz bar. Then I'll get my leads, which are underneath the webcam. Oh, great. Really planned this up well. So I'll put my positive in there, and I'll get my negative if I can find it, and I'll put it in there. Yeah, so let's get my multimeter out of the equation. And find the end of these leads and connect them to my multimeter. Switch it on to DC volts. Ooh, will be wobbly. Let's just zoom in on the display of that, and I'll stick that picture in picture. I'll stick that in number 2 or number 3. Don't really matter, does it? So if I now switch the power supply on, you'll see I've got 64.99 volts. I'm sure if I push that, it's supposed to track the two sides. So if I go down in voltage on this side, it goes down in voltage on the other. So I want to get down to about 50 volts is what I tend to zap them on. So yeah, we're around about 50 volts, look. So we want to bump the current up a little bit because we want to give it a good old zap. So this is a 5 amp power supply. So we've got some welly behind it. So that's the power supply. So we can come off of that now and go back onto the bench. So we can get rid of that precariously hanging webcam. Pop that out of the way somewhere, in under the bench. Hopefully it stays connected so as we don't have any issues. Right, there we are. So that's the, the Peak DCA 55. That's the component tester, isn't it? Because this is the DCA 75. So maybe that's a component tester then. It's like the older version. Right, so we've got our 50 volts. So our power supply dying away. Takes a while, doesn't it, to discharge? Didn't realise that. So it's got some discharge circuitry inside it. Let's get some stuff off the bench. So, don't need the meter anymore. We don't need our LCR meter for now. We'll need it back again in a minute. Right, so we've got our 50 volts available here. We need a capacitor now that can cope with 50 volts. And I don't know, through looking at other people's stuff, etc., I've sort of come to the conclusion that 100 microfarad seems to do the job quite well. I've never had a problem with this. So I've got 100 microfarad cap, and these are rated at 100 volts. So they need to be rated higher than the power supply you're putting them into. I know Simon Spires did a great little video on zapping them, but he used a high power supply, and I think he used a tantalum that could cope with the voltage, and he zapped them at 1,000 volts or something crazy. We're using 50. So let's do the worst one first from the IF section, then number 2. So what we need to do, let's just straighten up these legs a bit, because where I've pulled them out, they've got bent around and munched up here. I must make up a little jig for doing this, because I tend to do it quite a lot. I've never had one that's needed re-zapping, although I restored a radio for Rob Cross many years ago, which he thinks has got shorts again in the transistor. So I think he's going to be sending me that somewhere around about the Christmas time. So one of our Christmas live streams will be investigating the RP30 that I restored for Rob to see whether it has grown shorts again. I don't know if Rob's done any investigation as to whether, because I know he's been whacking it with something, so he may well have dislodged one of the pads on the board. Or it could be something like the tape socket gone a bit funny. Right, so I've just straightened them out anyway, because they're in a straight line normally. So what we want to do is make sure that we've got the shield wire. Let me just zoom you in. Let's zoom right in. So our shield wire, as I say, if it's going to focus, our shield wire is the one that's second in with the widest gap. So you've got the widest gap on this end, so that's collector, shield, base and emitter. So you want to move the shield wire out of the way. We don't want that one. We want to connect all these three together. So the collector, base and emitter need to be connected together. So I usually give them a little twist. It's not going to work this time, is it? Twist it the other way then, maybe. Yeah, give it a little twist. If you've got a third hand tool, you can just hold it in that if you want. And I just want to solder those three wires together. So what we're doing is protecting the junctions, because we don't want to zap between the junctions, because you'll blow the transistor up basically. Hang on. We're in setback. Just wait the soldering iron up a minute. So we've got solder now on the junctions, and you can see I've got the shield wire not in that. So what I tend to do is I use that. I do this the same way every time. I basically solder the positive side of the electrolytic to there. Let's not touch that while I'm doing that, Graham. It's difficult to do this while I'm got the camera and the third hand thing. So I'm just going to connect that capacitor. Come on, hold. Right, okay, so we've now got a capacitor connected to the base collector and emitter. You must make sure that that shield wire is free, because basically what you've got to do, you've got to put power across this capacitor. You're going to put power across the capacitor and then just touch that lead there to that one. So I've just bent that so you can see there is a little gap there. So the idea is to just touch those together when it's connected to the power supply. The capacitor will sort of, I can't remember, I know Bazaar said something about, I think it just acts as a buffer. You touch that, and that should blow away the shorts between the shield, or the can as it is, and the junctions. So that should blow them completely away. This sometimes goes right, sometimes it can actually go bang. So you need to make sure when you connect up that you don't put it the wrong way around. If I connect that to that and vice versa, it will go bang. You'll see that disappear in a cloud of smoke. So you must make sure that you put your positive on your positive and your negative on your negative. Yeah, so we're ready to go. Let's make sure that we can get it to touch just by moving it. I don't like to touch it with my hands. Yeah, so I can just about get that to touch. So I'm going to pop the power supply on. 50 volts in the house. So if we touch this together, we don't get anything. But that's not. It's very rare that you get too much of a reaction. Sometimes you'll see a little spark if it's a really bad short, but this one wasn't really bad, was it? So basically that's that one zapped. But don't forget, we've still got 50 volts sat on that cap. So what I do is I like to get a resistor, if I can find my resistor box. I just like to get a resistor and just short that one out, just to remove the voltage from it. Make sure we've got no voltage left in it. Because now what we're going to do is we're going to solder that wire onto there. So it's connected. So we're going to solder this one to that terminal now as well. So we're going to connect the shield to the negative wire. Can we do that in here? It just makes it a bit easier. If you can see it. Again, this is not my invention, don't forget. This is, I've got this from Mark Hennessy. I've posted the link many times. I will put it in again for reference in a minute. So now we've got our capacitor connected to that transistor, yeah? We've still got the negative connected to the shield and the positive connected to the other three junctions. So again, we're going to reconnect our power supply. And the idea of this next stage is to give it a bit of a tap. So let's just get you down and show you what I mean. So I'm going to pop the power supply back on again, make sure I've got the leads the right way round and they're not going to arc across and touch each other. Turn that on. So we've got our 50 volts sat across this transistor now. What we need to do is just give this a little tap with something non-metallic, ideally, to just make sure that there's nothing anywhere near the can. It's just a case, and be careful because I've done this before and I've knocked all the wires together. So I'm just using a hard screwdriver and giving it a little bang, and that really is just in case there's any little tiny ones that are very close to the edge of the can that are likely to short it back out again in the future. So I'm going to turn it over and do it on the other side. Turn the power supply back off. Disconnect the leads. So again, we've still got 50 volts attached across that, so I'm going to bleed that off with a resistor. You can sort of short them out directly, but then you're going to reduce the life of your capacitor by doing that. So just bleed. This is a 100 ohm resistor. It's 100% sure it's all gone. And that's that. Disconnect the capacitor. I'm going to leave that one connected up so as I know that that one's done, and we're going to move on to the next one, number 3. It's exactly the same job, so I'm going to rush through it a bit quicker now, but you get the gist of it. Exactly the same. Join all 3 legs together, bit of solder, so we've actually got 5 to do here. Normally you wouldn't have this many. If you've got the RP18, you've got 6 to do. So that's the hardest one, takes the most time. So again, we're going to do this one. We're going to connect the capacitor across it. Do it like that, make it a bit easier for me, wouldn't it? You don't have to connect the positive to the junctions. You just need to make sure when you put the power supply on that you've got the power supply connected to the right side, if you know what I mean. So make sure that's not going to touch any of those other wires. That's quite hot, Graham. Make sure that can touch quite easily. Power supply connected up again, exactly the same. Double check we have definitely got the shield wire. Power supply on, 50 volts, fire in the hole. Again, no issues, no sparks, nothing like that. Disconnect that. Discharge it. Solder the other terminal on. Connect it back up. Let's get that solder out the way. Fire in the hole. Hammer time. Turn it over. That should be job done. Discharge it again. Take off the leads. Another one done. Next one. we're zapping through them now, aren't we? My radio, good afternoon to you. Is that you, Adele? Okay, it never comes through as Adele. It's my radio, I think. I think that's Adele. So as I can say again, you'll have got this by the end of it, Don. You'll be bored to death of seeing zapping by the end of this. Is Don still here? Doesn't have to be a huge resistor like that. It's just I got a box of wire wound ones that I just use. So there we go again. Make sure we're definitely on the right one. Yeah, okay, so ready to go. Zapparoni time. Positive, negative. 50 volts. Fire in the hole. No spark or nothing. Again, this one didn't have any shorts anyway, but it might have had some very close to the edge of the case. Discharge. Let's connect the negative up. I should change these caps really, because I don't think they like being used in this way for long durations, but these tend to work. So again, positive, negative. Hammer time, fire in the hole. Pop him over. Make sure that's not too close. No, okay. That's a pretty hefty whack I'm giving it. So again, a bit of a discharge. Disconnect. Now we know that these have got quite bad shorts, so these might give us a little spark. You never know. You never know. So let's do this one first because it's got the pretty colours on it. Look at the pretty colours. So give you a better indication of which is a shield wire, which is the black one in this case. So connect these three together. Let's zoom you out a little bit. Save me keep zooming and moving around everywhere. Better to stay in one position at the moment if I can. Okay, they're soldered together. Oh, I need to solder the cap on. Come on, hold. Thank you. What's that message? Oh, thank you, Ben. Ben and Sandra, thank you very much. I don't know where that tip is, but thank you very much. Ever worked with a device that uses mercury switches? Yes, I have. Thermostats. Rechargeable 2032s. Okay. Right, so let's get this one ready for zapping. Need to make sure we can touch the leads, which we can. Again, make sure we get this the right way round. Negative to the negative side of the cap. Positive to the positive. Make sure we're definitely on the right lead. Yes, we are. I've done it before. I've zapped it with it not connected to the right leads, and that results in tears. See if we get a zap off of this one then. Oh, yeah, we did. I had a little snick then as I did that. Yeah, a little snick. Look, there you go. Let's turn that off. Zapping resistors. It's not connected. There it is. Yeah, normally if I'm rushing too much or there's too much beer gone in on a live stream, then you tend to see things blowing up where I've connected them the wrong way around. Right, okay, so fire in the hole. Again, 50 volts. Whacking time. Discharge. This would also work. Sometimes you find the AC 127s, 128s, OC81s and that. Well, no, not the OC81s so much, but some of those can grow whiskers and you can blow them off as well, I believe, in a similar way. That's that one. I'll put that one over that way because that's out of the other section. That's AF115. This is a bit higgledy-piggledy. Only had one beer, Graham. What's the matter with you? Might have had more than one last night. That's the only thing. Okay, so I need to make sure that we've got the right ones, which we have. This one's got some strange length legs on it. There we are. This is our last one. Then we're going to see if we've succeeded, got rid of all the shorts, and also whether we've killed the transistor or not, because sometimes zapping them can be a little bit too much for them, and they just die, and you've got to replace them. It's normally, I reckon, there's about, say, a 20% failure rate after zapping. So zapping can kill a transistor, so you need to make sure after you've zapped them that it is definitely still a transistor. We know they're transistors at the moment because it was working. Right, okay, so let's connect this one up. Again, we may see a little spark because these were the ones that were the worst. No, didn't hear a little zap then. I definitely did on the other one. I heard a little snick as I touched it, but that one's fine. That's had about 3 amps thrown up through it, so that one's going to be zapped. Let's connect that up. Take your time on it for your first few, Don, if you're going to have a go at them. I assume your radio's not working because an RP30 is unlikely to be working. Right, let's connect this back up again. Yeah, just take your time, do them. Spend a while. Don't rush it like I'm doing here. Fire in the hole. Hammer time. What I've done before is I've hit the leads and knocked them all together. That creates some fireworks, I can tell you. There we are. All 5 zapped. Now is going to be the time to tell whether we've still got transistors or whether I've killed the lot of them. So let's think positive and put all that out of the way. So let's get our transistors back together. So now they're all zapped, we just need to disconnect the solder from the legs. Should use some goggles for this, stop it going in your eyes. It's that one. So that's the ones from the oscillator. These are the IF ones. Cool. Twisted those together well, didn't I? I have got glasses on, so that does give me some protection from stuff flying into my eyes. Right, let's have a bit of a clean up. Right. The idea of the cap is you do put high current into them. Yeah, as I say, my current is set about halfway. It's a 5 amp supply, so I'm putting about 2.5 amps through them. Bizarre. I've got some mercury vapor tubes here. It doesn't matter which way around you connect the power supply as long as the positive goes to the positive of the cap. That's dead right, Don. You know, the ones I've used are just generic 100 volt, 100 microfarad caps. I've used those. People have said, you know, use other types of caps, all the rest of it, but when you've sort of got a formula that works, then why alter it? Right, so let's first of all check that we've got rid of the shorts then. So we know that number 1 and number 3 were clear of shorts, weren't they? Let me just write that on again, because that writing's rubs off. It's a permanent marker, but for some reason it rubs off. We know that number 2 definitely had shorts. Number 2 had shorts between the I think, was it the base was clear, but the emitter and collector both had shorts, didn't they? So let's connect this one up. Turn it on. Resistor mode. The other thing that you might find sometimes is you haven't cleared all the shorts. You might find that you've still got a bit of a short. If you have, you've just got to zap it again. There's a higher risk then you're going to kill the transistor. But let's try the collector first then. No, it's still 1.9 giga ohms left. Base. 1.9 giga ohms, and the emitter 1.9 giga ohms, so that is zapped. Whether it's still a resistor, whether it's still a transistor or not is another thing, and we get the goat in just in case there's any other cock-ups. Right, number 3 then. Next, these were the ones that were new. So there shouldn't be any problems with these. Fine. 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 Slightly different reading. That's just dirty leads. That's okay. And number 1. Again, this one didn't have any shorts. No. 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 Okay. All 3 of those good. So let's go to the ones that were in the oscillator section now. So that's the shortwave oscillator and the AM oscillator. Both had shorts. Bad shorts. Not like Hawaiian looking ones, but just bad shorts. So let's go, turn it back on again to the collector first. No shorts. Base. No, still in the giga ohms. And emitter. Still in the giga ohms. So that one is now clear of shorts. And the last one, collector, giga ohms, base, Giga-ohms and emitter. Giga-ohms. So we've cleared all of the shorts off of all 5 of those. But what we need to do now is make sure we've still got transistors. This is the interesting bit. Have we killed these or not? I mean, you could do this with a multimeter, but I've got a transistor tester, so I'm going to use that. So let's go with them in order. So let's do number 1 from the IF first then. So I'm not connecting the shield wire, obviously, although I've done that a few times and wonder what the hell's gone on. So we should be looking at a fairly good HFE on these. These are pretty good gain normally, the AF117s. So let's pop that on. Should, hopefully. Oh, okay. Right, let's make sure that we got ourselves connected the right way around. Have we got a dead one? Is it a dead one, Jim? Let's try that again. Let's just connect the leads, make sure they're all got good connections, and try that again. Doesn't like this one. Nah. Number 1 is dead. We've killed it. Oh dear. Number 2, this is the one that had the shorts. Again, we might have a problem with the leads on this one yet, so let's not 100% think we got this wrong. Let's see if they all show dead, then we've got an issue with the tester. But no, so that's still a transistor alert. So that's got an HFE. 0.4 leakage, HFE of 176. So yeah, it looks like we've killed one of the ones that was working, because number 1 was working, wasn't it? It could still be a transistor. I've had people say this before, that, you know, even though it doesn't read on these modern testers, then it's not necessarily dead. But I should have put them on the tester first, really, shouldn't I? But I don't tend to. I just zap them first and then see if they're dead. Right, this is number 3. Again, this is one of the newer ones. That one's fine, 207. So let's just double check. So far, 2 out of 3 good. Let me just double check this one, make sure I've got my leads right. If you got a dodgy lead or one that's a bit tarnished, sometimes they don't measure properly. Again, if you connect it to the wrong one. So let's just double check that. Is that 100% no good? No, that is a dead transistor, number 1, unfortunately. Because what that means is we're going to have to re-zap another AF117. Right, okay, let's hope we get better luck with these next ones then. So 1 out of 3 killed. Let's try this one then. This is one of the oscillator ones. I don't know if it's shortwave or the AM oscillator, one of the two, shortwave or medium wave, long wave. Fingers crossed. That one's good. He's good. If you can see that, yeah, that one's good. So number 1 is good. Let's try the next one. That's Mrs. Cruncher home by the sound of it. Yes, yes. Woo! Where are we? So we've got 4 out of 5 successful zaps. There's no point trying to zap that again, because that is now a dead transistor, unfortunately. So I know Simon very kindly, Simon's World, sent me some some pulls that he did. So I've got a stash of AF115 or an AF117, don't I really? AF117 with a sort of longer legs, if potentially possible. Yeah, that one's looking good. Let's have a look at that one. I've got a lot of AF117s that I've taken out of the modules, and the problem with that is they've got very short legs. You can use them, but you've usually got a job to stretch them. Okay, so I've got another one. This is another AF117, and it's going to replace this one, which is number 1. Which was that very top one that was just hanging in there. So let's check this one first. Let's make sure it is a transistor. Let's get belt and braces job this time. Let's not come unstuck. Okay, so it is a transistor. It is got good gain. Good news. Let's see if it's got shorts. Let's see if we've got any shorts. Apologies that I'm not checking the chat. It's very rude of me, but I'm sort of on a bit of a deadline here. I want to get these all zapped today if I can. Right, resistor mode. So connected up to the collector again. Sorry, the shield. So collector. Okay, that's, well, I don't know, that's very, very slight short there. Might just be a dirty lead though. Let's try it to the base. No, good. Okay, we've got a no. It's not too bad, that one. Yeah, not really got any shorts on that one. So we're going to zap it though still. We're going to zap it. This is going to end up being number 2, hopefully. So let's get zapping again. I put that back out of the way because I thought, nah, we won't need that anymore. But, you know. So if you've got lots of nice AF11456s and 7s that have got long legs that you've pulled out of equipment that you don't want, then send them on because I can use them. So we're doing exactly the same again, joining all 3 legs together. Popping our capacitor in. Making sure I've got zappage room. Yes, I have. Right, power supply still connected up. Make sure we got our leads the way around. Fire in the hole. No problem. Discharge. so we don't kill this one as well. There we go. Positive and negative. Put in the hole. Bang bang time. Flip him. Discharge. Put that out of the way again. Might be a bad omen, that. Disconnect these. Right, let's see if we've still got any, well, we haven't got any shorts. We know we haven't got any shorts, but we will just test it. You never know, we could have shorted the thing out, couldn't we? Let's test it anyway. I'll catch up with the chat in a minute, because I say, this is Cruncher, it's in the build. She might actually go out with the dogs. So yeah, 1.3 gigs, 1.7 gigs, 1.9 gigs. That one's not got any shorts. That's good. Hopefully we haven't killed this one as well. Yes! We're in business. There we go. So that is going to be our new number 2. And poor old number 2. I think it was number 2, wasn't it? It was number 2. I'm not sure now. Let me just double check. I think it was number 2. No, it was number 1 that had died. I forgot which one it is that's died now. Let's just connect them up and find out. That one's good. 391. That one's good. Was it number 3 that died? It was one of the ones that... Don't tell me that this is going to work now and I maybe had the lead connected wrong. That one's right. No! Don't tell me I've zapped that new one for nothing. I had a lead not connected properly, maybe. Yeah, all 3 of them are working now. What the hell? Guess I've got them mixed up. Wow. $279. This is the one I've just zapped. Now, which one had the mentally high reading? Was it number 1? I wonder if that one is on the edge. Yeah, this one is on the edge. Sometimes it's working, sometimes it's not. Let's just move the leads around a little bit. Try that again. Because it read something like 791, didn't it? No, it's definitely number 1. It's dodgy, although it came to life momentarily. So I'm going to put an X on that now, so I know that's definitely wrong. That's going with those. And that one is dead. Strange that it did come back to life though, isn't it? So there we are. Zapping done. I mean, that's got on quite well today as to where I wanted to be with it. Do we know what I've done with the radio now? Oh, it's over there. What do I do with the chassis then? Oh, chassis up here, yeah. That's the main thing I wanted to do, was get those zapped today. We have got some caps to do, but literally there's two in there. And it'd be nice to get those caps done. I need to find another cover for this thing here, because we want a bit of capacitor bingo with these two, don't we? Is there another one? No, these are all ceramic. So we've only got two caps to do. So I think what we'll do is we'll take those two out and we'll check them. And then we'll call it a day for today, because then we're at a point where we can start reassembling. And I've got to pinch one of these. In fact, I've got a spares box with some of these boards in it that people have nicked the transistors out of. And I think I've got another board myself where I've pinched one of these transformers that was open circuit. So I''ll get that put in. I also want to convert it back to its battery tabs. I will look at the pictures of the other Marine Herald I got, because this has got this socket on the side, which can be useful, I suppose, if you've got a power supply, but you're just asking for trouble putting a power supply in, because people will fit them backwards and all sorts of things happen, as you know. So let me just go see Mrs. Cruncher a minute, say hello. I think she'll probably be shooing off out with the doggies. If so, then we've got time to do that. Oh, I'm getting a bit stiff as well, so I need to be folding up fairly soon. Oh, my knees are seizing up. Right, Mrs. Cruncher's back from work, all okay. Gonna get these two caps done, get them replaced, and replace that other one. And then next week we'll get her buttoned up. Right, let's zoom out a little bit. Whew, and I need to catch up with the chat as well, because I've been slacking I've been slacking. Don's making notes. Excellent, Don. How come you can buy 2 times 4 in meters? 2 by 4 in meters? I don't know. Making notes, Motis. Right, let's just catch up with a chat a minute. And I'm going to crack open this second beer from our good friend John. Romsey Gold. Let's get that one underway. So I might need that to help me change the caps. Let's put the desoldering gun back on again. We've got hedge hop done. Very nice that was, John. So, you know, a thumbs up for Flax. Nice. Still not sponsored by anybody. You think one of them would now. One of the big conglomerate giants would have thought, oh, that guy, he has a different beer every Sunday. He likes to try different beers. We could send him some and he could test them for us and see what you know, get his opinion. Because he's had so many different ones that he should know what he's doing, shouldn't he? But they don't come. We must start getting some beers in for the Christmas situation. I really don't know what's happening with the live streams this year. I really don't know yet at the moment, so it's a bit up in the air. Any suggestions, put it in the chat. Look me up on Facebook, Radiocruncher, because I have got a Facebook group as well. So I've got a Facebook page, which is Radiocruncher, and I've got a Radiocruncher and Friends group, which is sort of invite only, but if you put an invite request in there, you'll normally get accepted. I did set it as auto accept at one stage, but it sort of diverted back. It wouldn't let me do that for whatever bizarre reason. I don't know. It must have had some reason. So yeah, look me up on Facebook and come and join in. You'll get to see some pictures usually of stuff I'm working on and stuff that other people are working on. And there's a messenger group on the back of that as well. So if you've got any questions, you can ask other people if I'm not about. Right. How are we going to work this? Because I've got to find a ferrule to put back in there, haven't I? Looks like there's a wire stuck in that one as well. Yeah, there's a wire stuck in that one as well. Get out, you little swine. Not man enough. I need the old forceps. There she blows. Yes, I think someone just cut the old transistors off and shoved some new ones in. That one, I don't know what they've done to that poor old ferrule, but he ain't no more really. Strange, it doesn't look like it's been chopped off. I might reuse that as it is. Right, let's put this first one in anyway. This force 330. Let's pop that one in. It's pretty much the same size, so we don't need to worry about dressing the legs too much. So we've got some couple capacitor bingo sessions coming up now shortly. A bit more room than the El Commode, which was vastly over its specified capacitance. Look at me with the big words. I'm not going to put the transistors back in at this stage. Right, let's get this next one out. This is 10 microfarads, and this has got the positive next to R9. And this is this Dali thing, and these are notoriously bad, but then I've said it before and they've been perfect. Come on, out you come. Ten microfarads, 12 volts, and positive and negative's not really marked on the board, but positive is that way. So I'm going to mark a positive on there just as I know. Because I've got the memory of a fish. About 5 seconds. As soon as I turn my back and come back, I'll have forgot which way I took it out. Back from cooking duties. Welcome back, John. Still haven't caught up, have I? Ben and Sandra, did thank you very much for the PayPal tip there via Stream Elements. Good curry. Do you need to connect minus to the shield, or it doesn't matter? It doesn't matter which way round you connect it, as long as you connect your wires correctly to the capacitor. So you can solder the negative lead of the capacitor to the junctions and zap from the positive to the shield if you want, but as long as you've got the wires the correct way round on the capacitor, it doesn't matter. Catch you soon, Sandra. Let's catch up with the chat. What would 400 kilovolts do to those transistors? Light emitting PMP. I know Simon did chuck some heavy. I think he charged it with a mega. He charged the capacitor up with a mega. Have a go at it, Don. I mean, what, you know, just make sure you got some spares. Zapping resistors, still there taking notes. This catching up. Have I ever worked on a device that used to, yeah, I thought we talked about mercury rechargeables. You got a B&O 448 with a mercury switch. I've got a mercury vapor valve here somewhere for that valve tester. Gavin wants a light massage. Don't get sozzled during the live stream. I've been known to be a bit tipsy before, Aaron. Especially at Christmas time. Come Christmas Eve, once I get playing that music, that's it. 50, 100 amps. Like cows. Oh, I had a big jump again then. Let's keep going. I'm sort of, I've missed loads of it. Christoph's in. How you doing, Christoph? I'm just going back. Blown it. Ken Surtees, how you doing, mate? You reverse powered a small electrolytic. What a bang stinking mess. Yeah, I had one that went bang that I had the wrong way around. Made me ears, deafened me. I lost me hearing in one ear. Cool, I've missed loads of chat, haven't I? Right, I think I'm up. I've gone back to Gavin's light massage. Blown it, yeah. Always, you do get one. I did say, didn't I, that some you can't. Some do die. They are good HFEs, actually. They always are on these. Always are, Ben. HFE bingo. Yeah, it was good assignment to send me some spare ones, wasn't it? A 20% failure, exactly, yeah. How you doing, Christoph? Is it worth kind of open to have a look? You can't, because it's difficult to get them apart. I've not really tried. There's such small junctions. You've got to get the cap off of it. And I don't think they're glass encapsulated, are they? I'm not sure. I think it's just like epoxy encapsulation. Yeah, a bit of zapping. I don't think it would make much difference, Aaron, would it? It's just literally would hold the charge more. I suppose you could charge up a 1 farad cap and keep zapping away without having to recharge it again. Thanks, Mike. You think the cover is missing due to the new socket shorting on it when they installed it? You could well be right there, Derek. Good thought. Yeah, I think you are right there. Mike's off. See you soon, Mike. Cheers, mate. Sorry I missed you going. Don, thanks for the tip, mate. What's the alcohol content? One was 4.5 and there was 4.9, Aaron, and I've just knocked my webcam on the floor. I don't know why they're so expensive, Bob, but they are nice. Sponsor me in my dreams. Yeah, but you know, you never know. One day. I ought to put it in the description, I suppose. Then people would wake up then. Yeah, the Hacker ones are very nice, aren't they? You're welcome, Tom. Don, I hope that's helped you, mate, and let us know how you get on. It'd be interesting to see how you get on. 330 in darts. Yeah. Fried bacon sarnies for tea. I had fried bacon sarnie for breakfast today, Aaron. Very nice too. Dids, hang on, what are you doing? Having watched a guy on YouTube who uses one of these instead of a power supply to zap the transistors. A Victor V. Ah, yeah. Yeah, that's one of those mega. I have got a Victor here. You could use that. I don't know if that was Simon or not. Somebody did do it. Don't we all get salted at Christmas? Yeah. I do it live on YouTube though, usually, Aaron, unfortunately. Visited a radio fair today. Cheers, Brett. Catch you soon, mate. And good luck with the pie hat. Well worth purchasing, mate, for that. Right, I'm up with a chat. Okay. Where were we? C17. I pulled it out. Dally, 10 microfarad, 12 volts. We're going to do some cap bingo in a minute. I'm going to swap that one out. Yeah, what's the bet? I got the wrong one first time. Yeah, of course I have. What have we got here? What have we got here in the 10 microfarad variance? We've got 63 volt one way over the top, but a 10 is a 10. And what was the other one? The other one was, I can't see that. I think it's a 40, but we'll get to that when we pull it out. So I'm going to put this one back in. So that was a positive. That side, negative from that side. Just solder this one in, and I'll pull the other one, and then we'll check the capacitor. It says cap bingo will commence. That's the Dally. And this is the one that's the wrong way around on the board. Actually, no, this one is marked. This one is marked. Ah, okay. Unusual. We've obviously sussed it for this particular one. Is that it there? No, maybe there. There we are. This one is marked negative in the correct place. In fact, they're both marked negative. Would you believe that? They're both marked negative. Well, we know that the positive is to the back and the negative is this way. So I'm just going to draw a plus there, so that's positive. So this is a 40 at 16 volts. So have a think then, 10 microfarads and 40 microfarads. Place your bets now. It's got a little blue lead on the positive, so I'm going to replicate that. Nice little touch. Hopefully be enough to reach down. So let's have your guesses for both then. 10 and a 40. A 10 and a 40. So that should be my 2 caps done. Or all 3 caps done. Right, here we go then. Eyes down looking. Let's get the ESR meter in the house. Put that on my stand. A broken stand. So, how are we doing? You picked up a Euro 4000 report on the fair today. €5! Wow. That's a nice bit of kit. Benji loves them. Benji loves them things. So, as I say, we've got a 10 and a 40. I'm going in with the 10 first. Have you placed your bets yet, everybody? This is the Dali. This is the one I've got least faith in. A 10 at 12 volts. Let's pour the rest of Romsey's gold into my glass. Or tankard even. Do you like drinking out of a tankard? I don't know what it is. I don't mind a sleever or something but like ales, I like to drink out of a proper tankard for some reason. I don't know why. Anyway, cheers everybody. Happy Sunday. How are we doing? Are we nearly all done? So we're looking for someone that's closest to both, aren't we? Now you're going to have to help me out here because I don't know. 89.7, Derek. So you're going 56 for the... You're going 56 for the 10, Derek, and 89.7 for the 40, are you? Is that correct? I don't know. I'm confused. Right, I'm going to push a button. Are you all ready? 10 microfarads is... Oh! Oh, hang on. Let's make sure we're not touching leads or anything like that. Oh, that one's not good. In-circuit leaky. Did anybody put... No? No good? Let's try this one then, the 40 microfarads. This looks like an old Philips or similar. Let's try this one. Okay, that one's not bad. 59 for the 40. Martin had 56 for the 40. 55 for Bob. 68. So 56 is closest so far. 65. 56 Andy B. We've got a joint hang on, 61. 61 is closer than 56. It's Christoph at the moment. Hang on, we got Gavin with a 59. Gotta be Gavin, isn't it? Got to be Gavin. Are you going to say open circuit, Benji, were you? It's Gavin. You got it bang on. You got an advert right at the wrong moment. Very good. Now this one's interesting. Let's put this on the LCR meter. Let's switch the LCR meter to auto. Let's put it on auto and let's just discharge this a minute, make sure there's nothing in it. Let's connect it up to the LCR meter and see what it says. It's on auto, so it should pick up any mode. Does it think it's a capacitor or... Oh, it says it's an open circuit capacitor. It's open. It's clearly connected, so open circuit. Just it won't let me even measure it as a resistor. It's just saying it's an open capacitor. Wow. How did it work, you know? How did it work? There you are. That's our bit of transistor zapping and recapping. That's our capping and zapping done. There we are. Anyway, I hope you've enjoyed that today. Those of you that haven't zapped a transistor before, watch this back and you'll learn how to do it. It's easy enough. You can do it with batteries. You can just join a load of PP3s together and zap it using that and a capacitor. You know, just these. And connect a load of these together and get yourself whatever you want. You know, you can get 50 volts. Connect 10 of those. How many volts? Yeah, 10 of those would be 90 volts, wouldn't it? Yeah, so say 6 of those together. Get a crock clip on each end with a capacitor and zap away to your heart's content. You don't need a power supply. So yeah, just some batteries you can zap with. So that's it for today, people. I'm going to go down and say hello to Mrs. Cruncher now. And next week we are going to be putting those transistors back in. I'm going to find a can for the missing transformer, and I'm going to see if I can work out how the original Marine Herald had the battery terminals wired up. I might still leave the socket in line, but I'll have to put a diode or something in there, won't I, so as it can't be connected to both at the same time. I'll have to have a think about that. There you are, people. Cheers, Les. Cheers, everybody. Have a good one, and you know, stay safe. And I'll catch you in the week, if not before. So, bye.